Hello everyone, welcome to Guided Notes 1-2 Matter Tree from Unit 1, Properties of Matter. In these notes we will look at the guiding question, explain the difference between an atom, compound, and mixture, as well as the different types of mixtures. So matter is defined as anything that has mass and takes up space. We classify all matter into categories. We start by separating pure substances and mixtures. Then the two groups are split further. Pure substances can either be elements or compounds, and mixtures can be split into homogeneous and heterogeneous mixtures. You have this in your notes already. It's probably a little bit easier to read. But matter is something that has mass and occupies space. We have two categories of matter, mixtures and pure substances. Under pure substances, we have elements, which is just one type of element. They can have like two bonded together. Those are like diatomic elements, but it's just one element. And then a compound is when two or more different types of elements combine, and that forms the compound. Now, mixtures can have two types. You're going to have two or more different substances combining. Now, if they combine where they have a uniform composition, or you can't easily pick one type from another, they're blended, that is a homogeneous mixture. If you can separate them, or you can pick one out, that is a heterogeneous mixture. So there are 118 known elements. These exist as atoms. An atom is the smallest unit of matter. All elements are listed on the periodic table. This periodic table of elements is an ordered list of all the known elements from smallest to largest. Elements are made up of protons, neutrons, and electrons. All atoms of the same element have the same number of protons. For example, hydrogen and helium are both elements. All hydrogen atoms have one proton, whereas all atoms of helium have two protons. So protons identify the element or give it its identity. So it's kind of like the DNA for an atom. It tells that atom who it is. So when two or more of the same element combine, they are still referred to as elements. However, when two or more different elements, so they're two different elements on the periodic table, they combine chemically to form a new substance with the atoms in a fixed ratio. That new substance is called a compound. Here are some examples. So up here at the top, we have elements. Right? Since there's two atoms, these are called diatomic elements. Di meaning two, atomic referring to atoms, so two atom elements, whereas the bottom here are compounds because they are made up of two different elements. You can have more different elements in here, but for simplicity's sake we only have two. But these have two or more different elements in them. The properties of a compound differ from the elements that they are composed of. For example, sugar is a white crystalline solid at room temperature. Sugar is a substance called sucrose, which has the formula C12H22O11, meaning it has 12 carbons, 22 hydrogen atoms, and 11 oxygen atoms. Looking at its breakdown, carbon is an element that is most commonly found as graphite, like your pencil lead, which is a black solid, or diamond, a very hard, clear solid, neither of which dissolve in water. Sugar does dissolve in water. Hydrogen and oxygen are both clear and colorless gases at room temperature. However, sugar is a solid at room temperature. When the carbon and hydrogen and oxygen atoms are combined and form sugar, the properties are very different from the original elements to the compound. The only way to separate compounds into their elements is through chemical means. Mixtures, on the other hand, can be physically separated into their component parts. Some methods of separating mixtures are filtration, distillation, and chromatography. Filtration, or gravimetric filtration, works the same way as a coffee maker works. A mixture containing a liquid and aqueous solution and insoluble solids, or there's chunky bits at the bottom, so solids that don't dissolve, are poured into a funnel containing filter paper. The liquid components are able to pass through the filter and are trapped in the container below, and the solids can then be dried in the paper and their mass found. Distillation is another method that separates substances according to their boiling points. The substances that have low boiling points turn into a gas first, because they have a lower boiling point, so they'll boil at a lower temperature. So as the mixture heats up, they will boil off first, and then they are condensed in this jacketed condenser and collected in the beaker. The substance with the higher boiling point will remain in the reaction vessel. So you separate the two there. Another method of separating mixtures based on physical properties is chromatography. This can either be paper chromatography, as we see in the picture, or column chromatography. Each one has a stationary and a mobile phase. So stationary doesn't move, so in paper chromatography that is paper. And the mobile phase does move, so paper chromatography, that is the liquid or solvent. The substances to be analyzed are either attracted to the stationary or mobile phase. The more attracted to the mobile phase the substance is, the further it travels through the stationary phase, or the further it will travel with the solvent. This method separates substances based on intermolecular forces, and intermolecular forces are the ability of a substance to stick to itself or another substance, if we remember that from earlier. We will return to this topic later in the school year. There are two types of mixtures: homogeneous mixtures that have a uniform composition and heterogeneous mixtures that do not. Homogeneous mixtures are considered solutions. A solution can be defined as a solute dissolved in a solvent. The solute is the substance that is present in a smaller amount. The solvent is present in the greater amount. Additionally, a solvent retains its phase. So if whatever's dissolving the solute is a liquid, like water, it'll stay as a liquid if it is the solvent. Homogeneous mixtures include alloys, which are mixtures of metals with uniform composition. One way of determining if a homogeneous solution has formed is to see if light can pass through it without being scattered. This is the Tyndall effect. Heterogeneous mixtures do not have a uniform composition because the particles are larger or because they do not combine. So here is a chart that shows different combinations of phases and the names of each. Make sure you remember to write in air. So what kind of matter is baking soda? If we look at this, we see 1, 2, 3, 4 different elements in a specific ratio. So we have 4 elements in a fixed ratio. Okay, so it is a pure substance because it's just that. It's not multiple things, so it's a pure substance, just baking soda. However, it is more than one element, so we would say that this is a compound. Okay. So for the we do, you will scan the QR codes and complete them on your own. And then for the you do, you will complete these on your own as additional practice. Refer back to your notes for any help or material that is included in there to answer these. It should all be in there. And then after you've finished everything, answer the guiding question at the end of your notes. Thank you. If you are absent, you can upload it to Schoology or turn it in when you return to class.